In the next two examples, we're going to use the elimination method of simultaneous equations when the coefficient of the variables in both equations is not the same, which means that we need to do some manipulation to one or both of the equations first. So once again, as always, label your equations. So you'll notice here I've got a 6 and a 2 and a -2 and a 5. So what I can do is I can essentially just multiply equation 2 by 3 to make my x's have the same coefficient. So I'm going to multiply equation 2 by 3. So now I'm left with 6x plus 15y equals -24. Remember, you're not just multiplying this one thing, you must multiply everything. And then we rename it. Like I said, you can call it equation 3, but I like to call it 2a, so I know that this one is a variation on this equation. Now I can solve by using elimination method. One other little trick that I like to do though, because we're adding and subtracting our equations, I like to rewrite the other ones so they're lined up nicely and I can keep track of what I'm actually calculating. So because they both have a positive coefficient, I need to do equation 1 minus equation 2 because 6 minus 6 will equal 0. So now I've got 15 minus -2, so I've got 17y because that becomes 15 plus 2. Same here, so I had -24 minus 10. So in this case, I've got -34. And I solve as normal now. So I've got y equals -2. As always, we never just get one answer. Every coordinate has an x and a y. So now I'm going to sub y equals -2. Remember again, you can sub it into any equation you like. I tend to be quite lazy and just sub it into the first one. Not lazy, but just it's the most convenient, I guess. Okay, 6x plus 4 equals 10. And now solving as normal. Then write your final answer as a coordinate. Remember, we need to be making connections between our graph, our equations, and our coordinates. Next example. Step 1, as always for this example, let's label our equations. Now, if you can look at it at the moment, they don't have any, I guess, common factors or common multiples. So what we'll need to do is we'll need to either multiply to make both of our x's have the same coefficient or both of our y's. I tend to like to work with smaller numbers. So what I'm going to do is I'm going to multiply this line by 3 and this line by 2, and then I will have a coefficient of 6. So I'm going to do line 1 multiplied by 3 and equation 2 multiplied by 2. So now I'm left with 6x plus 15y equals 30, and this becomes 1a. Then I've got 6x plus 14y equals 28, and that becomes 2a. Now I can solve as normal, so I'm going to do equation 1 minus equation 2. So now I've got 6 minus 6 is 0, 15 minus 14 is just y. We can write 1y if we really want to. 30 minus 28 is 2. Once again, we always have an x and a y, so we're going to sub y equals 2 back into any one of these equations and solve as normal. 2x plus 5 times 2 equals 10. 2x plus 10 equals 10. You're sitting there going, uh-oh, something's amiss. You can have a 0 answer, so don't stress if that happens. 2x equals 0. I'm still going to finish all of my steps of working. X equals 0. It just means that that point passes through when x equals 0. That's a y-intercept, isn't it? So again, we write our coordinate, therefore x and 0 and 2.